Most people working with Windows know about this thing called session or sessions, but what are sessions exactly? We have some intuitive understanding of what session probably might be, but this term in general is somewhat overloaded. So what is a session in Windows? Welcome to this video to describe that. So what are sessions? First, we have the idea that the term session is actually overloaded, even within Windows itself. One term is the console session, which is something that is basically what people usually think of when looking at a session. If I log in into the system, then I get a session. If someone else logs in into the same system, they get a different session. If someone logs in remotely, they get another session. So that's what we typically, maybe intuitively think of as a session. But in this video, I want to get to the details. What exactly is inside the session? What is a session anyway? So a session is just a kernel object. It's one kind of kernel object representing resources that are being shared by all processes that belong to that session. So it's kind of a way to share stuff, and we'll see what that stuff could be in the next slide, between processes that belong to that session. In most cases, this is based on some logon, which could be an interactive logon or remote logon. It's not necessary to have that technically, so a session could be created differently, but that's the most common case. I would say the other case is when we have session 0. So session 0, it's always there in any Windows system. This is the session where processes that belong to the system, so to speak, run in. This includes all the system processes like SMSS, CSRSS. Well, CSRSS actually is kind of special because there's one copy of CSRSS per session actually, but SMSS, the global one, is just part of session 0, and also most of the Windows services run under session 0. So they can share certain things in an easy way by being part of that same session. And so a process can belong to a single session, and it always belongs to one session, and something that you can't technically change. So a process is born part of some session. In fact, we can open Task Manager, we'll click here and see that there's a session ID here as a column we can add. If you don't see that, just right click on the columns area, use select columns and look for the session ID column. And you'll find that a typical Windows system, you have two sessions. Session 0 is always there. So all the, like I said, Windows services, I created a video about services elsewhere, so you can find that on my channel. And so session 0 is used for these services mostly, and various system processes. So if we look at processes at the top, like the system process, which really representing the kernel, so it doesn't really count, but still it is part of session 0 technically. And we have things like the some SVC hosts, and some other processes that are used by the system or are simply services, and they're part of session 0. And then we have session 1. Session 1 presents my login. The fact that I'm interactively working with the system means I have my own session, and this is represented by this ID, session number 1. If I go to a virtual machine that I might be using, then I might have even more sessions, and we'll see that very soon. And so a process is always part of one session. Now the other term where session is sometimes used is called a logon session. A logon session is a different thing, although it has some connection to a console session. It represents some kind of login. It doesn't necessarily mean there's a console session for that, but it is some kind of login which could be remote or local. And in fact, it is the source where access tokens come from, so to speak. And we'll discuss maybe logon sessions in a separate video. This video is about console sessions, like the classic or perhaps the more intuitive term known as session. Okay, so what do we have inside the session? So here it goes. A session is a kernel object, but it's a container of other objects, which of course are shared by all processes part of the session. So first we have this idea of process that belong to session. So this is just a little example where I have process A and process B that belong to some session we're looking at here. And then the first thing that session has is another set of curious objects called Windows stations. So Windows Station is yet another kind of kernel object that in itself is also a container of some other kinds of kernel objects. And there's always one Windows Station at least in every session, which is called Win*0. It has like this hard-coded name, and this represents the interactive Windows Station, which means that this is the only Windows Station that can present, say, UI and interact with the user. But you can create other Windows Stations which are hidden, but you can attach processes to those Windows Stations. So in this little example, we have process A that is part of this session, but it is attached to this Windows Station. This process B, it's part of the same session, but it is attached to a different Windows Station. So why does it matter, and why would I want to create Windows Stations to begin with? So let's dig deeper into Windows Stations, what each Windows Station contains. So here goes. The first thing is desktops, which seems kind of maybe weird. So Windows Station is a container for desktops. What are desktops? Desktops are those surfaces on which we can create the windows, for example. And so a desktop is actually a kernel object. So it's a secure kernel object just like any other kernel object. And by default, we have two desktops we're familiar with. One of them is called default, and the default desktop is where you see your windows, the stuff that you work with in the operating system. So in this case, you see my PowerPoint slide here, which is part of a PowerPoint process that belongs to the interactive Windows Station Win*0 in my session, and that PowerPoint window is shown on the default desktop. So desktop contains windows at least, and we'll see a few more details very soon. And so we have the default desktop. There's another one which you also are very familiar with, but you might not have thought of that as a desktop, which is called the WinLogon desktop. So we're very familiar with the classic key combination of Control-Alt-Delete, which is called the Secure Attention Sequence, or SAS, by the way. And Control-Alt-Delete is just the default. Technically, it can be changed. But if we press Control-Alt-Delete, we get a different view. We see something different. We have these options like lock the computer, change password, launch Task Manager, things like that. Where is that actually coming from? Is that just replacing my usual windows with some other window? Well, not quite. In fact, what we see is a different desktop. This is the desktop that is managed by the WinLogon process. So in fact, there's a Windows API you can use called Switch Desktop that can switch to a different desktop. Now, the WinLogon desktop obviously is highly protected, only mostly allowing access for the system, local system account, and not some arbitrary user, in order for others not to be able to meddle with that desktop, like present some other options which don't make perhaps good sense from a security perspective. But that's what happens when you press Control-Alt-Delete. Switch Desktop is being called, and you see a different desktop, which means that your desktop is perfectly intact. The default desktop hasn't changed. And once you press some kind of thing to some kind of option like go back or launch Task Manager, then the system calls Switch Desktop again to switch back to your default desktop. Sometimes there's a third desktop, by the way, called the Screensaver Desktop, which is not as popular as it used to be in the old days. And technically you can create other desktops. In fact, there is a tool from Sysinternals that allows you to create multiple desktops. Now, one thing I want to mention here is that you shouldn't be confused with the virtual desktop features Windows 10 and Windows 11 have. They seem to be able to allow you to create more desktops because you might have a very cluttered work environment on your machine, and you want to have multiple desktops, each one working with different windows there. So that makes sense, and the virtual desktop feature is fairly convenient. However, do note that every time you create a virtual desktop, this is not a true kernel desktop object. And the reason for that is for flexibility, which goes against security, but it is what these virtual desktop features are trying to achieve. Because if you have a window that is created on a particular desktop from a kernel object perspective, it can never be moved to a different desktop. That's where it lives. More technically speaking, a thread lives within a desktop, and a thread, once attached to a desktop when it creates its first window, cannot be moved out of there. And so The virtual desktop features in Windows makes it easy to move windows between virtual desktops because there's no real moving going around. It's still the same desktop, the default desktop from the kernel perspective, but it's just that the visibility of those windows is being meddled with by Win32k.sys, the Windows manager in the kernel. So just know that this is different than the real desktop kernel object. But the desktops tool from Sysinternals does allow you to play with that. It allows you to create up to 3 more custom desktops, which you can switch between using some hotkeys, and that these are true desktop objects. So if you launch Notepad, say, in one of those desktops, you can't see it when you're looking at a different desktop. You have to go back to that desktop to interact with Notepad. So these are desktops in a nutshell, and we'll see what they contain very soon. Another thing we have in the Windows Station is Clipboard, which seems perhaps a bit surprising, but if you think about it, it makes a lot of sense. Well, at least some sense. I mean, let's say I'm pressing Ctrl+C and there's another user logged in on the system, and that user presses Ctrl+V, maybe from a remote session. Should that user see my data? Probably not. That doesn't make sense. So the clipboard can't really be global. At least it must be as part of a session, but in fact it is part of a Windows Station. So one reason maybe to create another Windows Station is that any process that is there it has its own clipboard, because that clipboard is going to be part of that Windows Station. So it means that nobody can steal data from that clipboard even running on the same session, because it's a different Windows Station. So clipboard is a Windows Station related object and not a session related object, and definitely not a global object. The last thing that Windows Station contains is an atom table. An atom table is a data structure. It's like a map that maps the strings to integers, which are used by certain Windows user interface APIs. That's the kind of the official way to use atom table. And an atom table is also part of a Windows Station. In fact, if you think about handles to Windows, this is the way to represent a particular window. It's actually local to a Windows Station. So Windows Station kind of gives out handles which are only bound to that Windows Station. So you can have 2 windows that have the same handle value, but they can belong to different Windows Stations, and there are different windows there. They cannot really interact. So an atom table has actually been used maliciously using a technique called atom bombing, which is something you can find online, see exactly what that means. And the main idea there is because the atom table is part of Windows Station, it can easily be shared. It is shared between all the processes that are part of that Windows Station, which means that we can potentially use that as a mechanism to pass along data, specifically shellcode, and then somehow persuade another process to run that shellcode. That's kind of in a nutshell, but you can find more information online. Okay, what do we have within a desktop? Within a desktop, we have first and foremost Windows. These are those most rectangular areas where you can display stuff. So Windows are part of a desktop, and we mentioned that already. Also, menus are part of desktops, but it's not really that interesting. Menus are just kind of specialized windows. The more interesting, perhaps, part are hooks. So the term hook itself is very overloaded. We can have many kinds of hooks depending on the context. But in this case, the hooks I'm referring to are the ones that you can create using the function set Windows hook EX. In fact, I demonstrated that function in an earlier video a few years back. So feel free to go and watch that. But the important point here to note is that hooks are always bound to the current desktop where they are installed. So for example, if I want to have that kind of hook installed on the WinLogon desktop, I can't do that for my desktop. So it only is able to intercept, say, Windows messages that are part of threads that are bound to the current desktop only. And this makes it more difficult, of course, to attack other desktops, for example, the WinLogon desktop, to try to put a hook there to see what is going on and capture, say, user names and passwords or whatever is happening on that desktop. So that's kind of, in the nutshell, what you find in terms of a session, what that session contains. Here's another process C, just for fun, that belongs to the same session and also shares the same Windows Station as process A. So can we see that information in some tools? Let's go ahead and give it a shot. So we looked at Task Manager, but that's not really that interesting. One way to go about it is to launch WinOBJ from Sysinternals or my own Object Explorer, which is going to give you a similar detail. And I'm going to launch that with admin privileges because I need to show a few things which are not shown by default by having a non-admin user. So you can see there's a session directory here in the kernel object namespace, and you can see there's 0 in 1, so that we have a session ID for each one of the sessions on the system right now. And if I open that up, there's something here called base named objects. So base named object is where named objects are or living when we create such named objects. They're always session relative. So let's say I'm calling a function like create mutex and I give it a name like my mutex. Where is it actually going to land? And the answer is right here within this directory in the object manager namespace, automatically bound to or indexed by my session ID, which means that another session, a process running within another session, calling the same create mutex function using the same name like my mutex, creates a completely different mutex, which is not being confused with the mutex that I created because it's part of the other session, say session number 2. I also want to mention here that session 0 actually, their objects are under base named objects directly under the root, but basically the same idea. This is where session 0 namespace is from that perspective. Another thing we might want to look at are session objects. So session objects are just kernel objects and they do have names. So technically you can see them here in the kernel objects directory. You can see the session 1 and session 0. These are the session objects. So these are the ones encapsulating all that information that I mentioned earlier. What about Windows stations? So if we go to Windows here, and we can see that there's Windows here under session 1, and this shows us some information related to UI stuff, and one of them is a set of Windows stations. So you can see there's a Windows station called Winsta0, which always exists. So that's the only Windows station that can use input devices, so that's always there. But there could be other Windows stations that are created for whatever reason. In this case, we have a Windows station with a weird name called service 0 something, and this represents a Windows station created for some service. I won't go into the detail of why that name looks the way that it does, but this is another Windows station which is of course non-interactive, and it's being used by some service process. We can't tell any more details about that using this tool. We have to, if you want to know some more, get some more information, we have to try using some APIs, and maybe we'll do that in a future session. The Windows we see here, the Windows stations, is the Windows station for session 0. So for session 0, you can see there are multiple Windows stations. One of them is Winsta0, which is always there, as I mentioned, but there are others. You can see most of them have the same kind of name, and in fact they belong or they're used by services that are running, at least these 3 are used by the services running under classic Windows accounts, local system, network service, and local service, and the numbers you see here are actually the logon session ID, and that kind of connects us indirectly to the logon session concept which I mentioned at the beginning, but is not in scope for our video here. And there are some others that have been created by something, and we don't necessarily know who created those Windows stations, but they're part of the same session number 0. If I go ahead and try the same kind of experimentation in my some virtual machine I have here, so I have a Hyper-V virtual machine. So if I open up Task Manager, we can see that in terms of sessions, there's session 0, which is always there. There's session 1, but there's also session 2. By the way, notice that CSRSS, I haven't talked about CSRSS in these videos, but just know that there's one CSRSS per session. And that's the Windows Subsystem Process Manager, so to speak, or something. You can think of that as a helper to the kernel for managing Windows processes, and we have 1 copy per session right here. So there are 3 sessions here. So if we open up WinOBJ, we can try to get some more details just like before. So let me launch that with admin privileges again. Otherwise, we won't be able to open the sessions directory. So now you can see there's a 0, 1, and 2. So we have now 2 here because I'm logged in here locally and also logged in remotely using the remote desktop services, so to speak, to that virtual machine. So each one has their own set of Windows stations, just as you would expect. So you can see session 1 has 1 Windows station, session 2 has actually 2 Windows stations, and Windows 0 is always there. There's always session 0, of course, that never goes anywhere. It must exist, and you can see it's right there. In terms of base named objects, again, we see here a bunch of object names, and these names represent objects, kernel objects that have names that have been created by processes that belong to session 2. And same goes with session 1. And these names might be identical. It's definitely possible, but there's no confusion here because the full name is based on the full path, starting with backslash, which is the root of the object manager namespace, all the way to the actual object in question. So every session has some kind of boundaries, and this is known as the session namespace from a naming perspective, because many kernel objects can have names, and if they do have names, by default the Windows API will place them in the appropriate directory based on the session ID of the caller. So this is what we can find here. What about things like desktops? Can we get information about desktops? We know that every Windows station potentially can have desktops, either one that we see here, or maybe some don't have any desktops. Anything is possible, but how can we see those? Well, that's more difficult because there's no direct way to see that in this particular tool or in other similar tools, because they're not really stored as part of the hierarchy. They're stored in kind of a local way inside a particular Windows station. And we can try to enumerate desktops just like we can try to enumerate Windows stations by using some APIs. But we have some kind of limitations there from API perspective. Maybe I'll show some of these APIs and give you some more details in a future video. But hopefully you get a sense of what's going on here. Just as a quick intro to that, if you do want to see what desktops you have on your current Windows station, there's a num desktops function that you can call to get a list of all the desktops that you have. And technically you can create new desktops like I mentioned, and the API to do that is called create desktop. So I might discuss these APIs because they are definitely interesting, I think, and I will discuss them probably in a future video, and also talk about sessions a bit more from an API perspective. What can you actually learn about these sessions there? But for now, hopefully you have a good sense now what sessions are and what they contain.